Juniper Network's Session Smart Router's implementation of connectivity while using traditional routing protocols like BGP and OSPF relied on their standardized hello mechanisms. Normal BGP timers utilize a hello, forwarded along to neighboring routers to advertise routes with a timeout of about 30 seconds. Your Session Smart Router's default behavior in this scenario was when the originating router hadn't heard for 3 hellos, it times out, around 90 seconds after the first one. This is a long period of time to wait for possible connectivity. With the introduction of bidirectional forwarding detection, BFD, sent over route advertisements in BGP and OSPF, your Session Smart Router gains connectivity insights exponentially faster. How much faster? Well, while these values are customizable, admins can now measure failovers in milliseconds compared against entire minutes after the previous series of missed BGP hellos. To better understand how BFD is superior, let's outline the previous Band-Aid solution to identify connectivity issues over traditional routing protocols, which was to simply adjust the timers. However, BGP and OSPF protocols are not designed to have their timers tuned, and this fix still puts a hello timeout measured in multiple hello attempts, resulting in a long wait for connectivity. When you compare this to BFD, which is designed to detect connectivity, and quickly, the new solution solves several of our previous challenges. The industry-standardized BFD detects liveness along the standardized UDP ports 3784 for single hop, 4784 for multi-hop, and 3785 for echo packets. The BFD standardized ports don't conflict with the proprietary BFD protocol that runs between your Session Smart routers on port 1280. And this means that the new application won't interfere with the current BFD protocol between Session Smart routers. But it also means that the new implementation of BFD will not impart the same level of information as Session Smart router's proprietary BFD. The Session Smart BFD relies on enhanced multi-hop BFD to monitor links and gain performance insights like jitter, loss, latency, MOS all along your Session Smart paths. This makes sense, as our new implementation of the standardized BFD is for interoperability with other vendors. With your Session Smart's new implementation of BFD, we function better with other vendors. Let's say there are 2 data centers, and a link to one of them goes down. With the BFD mechanism in place, we fail over quickly to the other data center while using BGP. It's important to note, with BFD, if there's a neighbor running both BFD and OSPF, it would be one BFD session, as the routing protocols can all share the same BFD session. Again, this is not to replace BFD between Session Smart routers, which adds several layers of information and connectivity over simple liveness detection. There are other Session Smart proprietary solutions for failover in this case. Leveraging BFD simply detects when it peers down a lot faster when compared against BGP and OSPF keep-alive methods. While BGP and OSPF do have methods to check to see when a neighbor or adjacency goes away, it takes a long time. This BFD implementation is a dedicated protocol to solve that problem. The time problem. BFD can be hundreds of times faster, measured in milliseconds, not seconds. Other vendors have implementations of BFD, and this new Session Smart Router application of BFD leverages that communication over BGP and OSPF to provide a more reliable network. Before we dig into our demo, let's explain this topology. Here you can see I have 4 routers with a BFD session between these 2 BGP peers and 2 OSPF peer routers in between. The BFD runs between these OSPF peers. It's important to note. To demonstrate the BFD down, I'll cause a breakdown in a midpoint router, which will cause connectivity loss between the BGP peers, resulting in that BFD down detection. So let's take a look at a failover in action using BFD. I'm going to break a BGP connection and replace it with a BFD session to ensure connectivity. Here, I have a few connections running in OSPF. For DUT5, which is one of these midpoint ones, I have an OSPF session on this WAN 60 interface. So if we bring down OSPF, that will break the communications between DUT2 and 3, which is running a BGP session. So let's go ahead and delete the interface out of OSPF and then commit it. Now, let's use some common troubleshooting commands like show OSPF to get a better look at the router. And as you can see, the session is gone. When we do the same thing to get a look at BFD with the show BFD command, these are the 2 we're interested in right here. And it should be down, and it is. Lastly, we'll use the show BGP summary to see if BGP is established, and it's not. So let's go back. And what we'll do is we'll bring BGP up by enabling the interface and BFD. Now, while we wait for this to refresh, I'm going to cycle through the show commands we've used already, including show OSPF, show BFD, and show BGP. This should take just a moment for it to come back up. Over here, take a look at the BFD. And there it is. Now let's take a look at the BGP. And it's up. And that's how simple it is to use bidirectional forwarding detection, BFD, over traditional routing protocols to ensure connectivity.